Welcome to Kepler's training video. Maybe one of a significant amounts of questions in the CCNA examination is about the subnet calculation. Something like, what is the size of a subnet for a particular prefix length? Are these two IP addresses in the same subnet? What is the first or the last available IP address of a subnet? So, without an effective way for the calculation, the chance of failing in the examination will be quite high. Unfortunately, in the CCNA class, it teaches you how to use the binary for the calculation. However, who get used with the binary calculation? Do you use binary in your daily life? Will you go into the supermarket and then buy, say, 10110 pounds of meat? Oh no, you won't, right? We're only familiar with the decimal calculation in our daily life. Therefore, in this video, I will teach you how to use the decimal for the subnet calculation, and also how to visualize how the subnet is being divided into different portions. It's just like a piece of cake. Let's review the concepts of subnet first. Subnetting actually divides the original logical networks of a major class into smaller logical networks. How can we do that? We take some bits from the original host part to extend the network prefix, like in here, 10.0.0.0/8, as 10 represent class A network. And this network number uses the default prefix length of a class A, that is 8 bits. So this is the major class number. Now we can divide these major class numbers into some subnets by taking some of the bits from the host part. For example, we can take 8 more bits from the host part as the subnet bits, so that we get a 8 plus 8, which is 16 prefix. For example, then we can have 10.1.0.0/16. Similarly, 10.2.0.0/16. Those are the subnets of this major class number. You can also treat the original host part as a ranges of IP address. So subnetting is simply divide these ranges into smaller ranges. How many ranges you get? Depending on how many original host bits you taken out to form the subnet bits. As in the previous example, I take 8 bits to form the subnet bits. For 8 bits, it can range from 0 to 255. That means I get 256 smaller ranges. That means if we take 1 bit, as 1 bit can only vary from 0 to 1, so we get 2 ranges. If we use 2 bits, that is 4. 3 bits is 8, and so on. Actually, it's 2 to the power s numbers of small ranges we get, where s is the numbers of subnet bits. Then what about the size of each range? It depending on how many host bits are in each range. If we take 2 bits, in fact that is the smallest subnets. You cannot take 1 bit. I will explain it later. So for 2 bits, you get 2 to the power 2, which is 4 address in this range. If we take 3 bits as the host bits, then we get 8 address. And then the next one is 16, 32, and so on. That means you can get the size of the 2 to the power h address in each range, where h is the numbers of host bits. First, if you want to get more ranges, then each range will have a smaller size. I will use a Class C network number to illustrate the detailed calculation first. Then I will come back to Class B and Class A. Now let's see, for example, we want to divide this 192.168.1.0/24, which is a Class C network numbers, into different sublets. For a Class C network number, you have the last 8 bits as the host part. You can borrow some of the bits from this host part as the subnet bit to get different numbers of sublets with different size. You don't even care about the first 3 bytes. That means in this example, actually it works for all the Class C network numbers. Now let's take a look on this last 8 bits. In binary, this last 8 bits ranges from 0, that's all 8 zeros, and then 0, 1, 1, 0, and then so on, up to 8 different ones. The decimal equivalent is from 0 up to 255. In here, I just use the binary to show the correctness of my calculation. Believe me, you can forget the binary later for the actual calculation. To visualize the concepts of how to divide these 8 bits into different ranges, I will use what I call the cutter cake model. Imagine that there is a large cake with 256 pieces. Each piece is labeled from 0 to 255, arranged clockwise with the 0 on the top right hand side, all around to the last pieces, that is pieces 255 on the top left hand side. Just like the diagrams in here, as it's too hard to list out all those 256 labels around the circle, I just write down some of them. Something like the last numbers of the first half is 127, while the second half start with 128. Let's discuss the case of /25 first. That means we borrow 1 bit from the host part. The highest bit of the host part can just vary from 0 to 1. That means it divides into 2 different portions, or 2 different sublets. The first sublets, or the first portions, start with all zeros up to 0 and then 7 ones, while the second portions start with 1, 7 zeros, and then up to all ones. In decimal, the first portion starts with 0 up to 127, while the second portions start with 128 up to 255. What happened to the cake? That means we divide the cake into 2 different portions. Each portion will have 128 edges. It is 256 divided by 2, right? So the right portions begins with 0 up to 127, while the left hand side portions begins with 128 up to 255. Each portion is a sublet. That means we get 2 different sublets in this case. Of each, we have 128 IP addresses in each range. Now let's take a look at the case of /26. That means we consider 2 highest bits as the sublet bits. We focus on the first 128 addresses first. The highest bit of these ranges is 0, but now the second highest bits can vary from 0 to 1. That means we divide this portion into 2 more portions. In binary, the first portion starts with all zeros and then up to 2 zeros followed by 6 ones. The second portion starts with 0, 1 and then 6 zeros up to 0, 1 and then 6 ones. In decimal, the first portion begins with 0 up to 63, and then the second portion begins with 64 up to 127. It applies for the next 128 addresses. That means we further divide the next 128 addresses into two same size portions, of each have 64 addresses. Now we go back to our case. Recall that in the case of /25, we divide it into two different portions. Now in the case of /26, we further divide these two portions of each into two more portions. That means right now we will get 4 portions. Each portion will have 64 addresses. The first portion begins with 0, second portion begins with 64, third portion begins with 128, and so on. If you are more mathematical mind, then you will notice that each portion begins with a number that is a multiple of 64. Then what about the case of /27? This time, I won't use the binary to expand anymore. In fact, when you take one more bit from the host bit as the subnet bit, you simply further divide the portions you get from the previous prefix length into two more equal size portions. So, in the case of /27, we simply divide the 4 portions we already get in the case of /26 into finally 8 different portions, and each portion will have a size of 32 IP addresses, just like the diagram shows. Now our cake is divided into 8 different portions. Now, let's take a more detailed look on each portion. Each portion represents a range of IP address of a subnet. The first numbers of each portion represents the subnet itself, as these numbers has all the host bits at 0. In fact, that's what you will see in the routing table. For example, in the case of /27, the numbers 0, 32, 64, and so on are the subnet numbers, while the last numbers of each range is the broadcast address of that particular subnet, because the host bits of these numbers are all 1. For example, once again in the case of /27, the number 31, 63, 95, and so on are the broadcast address, as the first and the last addresses of each range have special purpose. The usable IP addresses of each subnet becomes the size of the range minus 2. For example, in the case of /27, in each subnet, there will be 30 usable IP addresses. Obviously, the first available address is the subnet numbers plus 1, while the last available address will become the broadcast address minus 1. For example, the subnet 32 in this diagram, the first available address will be 33, while the last available address will become 62. Once you understanding how to divide network numbers into different subnets, as what I just discussed in my previous slides, you should be able to answer one of the common questions in the examination. That is, by giving you an IP address, you should be able to figure out the subnet this IP address belongs to, and the broadcast address of that particular subnet, also the first and last available address. That is, you need to figure out which portions this IP address belongs to. Now let me ask a question. What will be the first information you want to find out for the calculation? Some of you may already be aware that that is the size of the sublets for a particular prefix length. Because once you find out the size, as I mentioned before, then the sublet number will always be the multiple of the size. So you just need to find out the multiple just less than the IP address. This is the sublet number this IP address belongs to. After that, other informations are trivial to figure out. For example, the broadcast address will be the sublet number plus the size minus 1. Then how can we find out the size? When I teach the CCNA class, sometimes some of the students may suggest this method. You first find out how many numbers of sublets first, and then use 256 divided by these numbers of sublets. But then how can we find out how many sublets? You need to first figure out how many sublet bits first, and then use 2 to the power of these numbers of sublet bits. Say for example, for /27, numbers of sublet bits is 27 minus 24, that is 3 bits, and then 2 to the power of 3, you get 8. This is 8 different sublets. And then use 256 divided by 8. Then you get the size of 32. It sounds a bit complicated, right? The drawback of this method is that this is class C specific. And also, you need to do a division. Do you like division? Most likely, people like multiplication rather than divisions, right? So, there is another method which will be more directly. Don't focus on numbers of sublet bits. Instead, focus on numbers of host bits. Once you figure out the host bits numbers, then just use the 2 to the power of this number. You already get the size of each sublet. Then what is the numbers of host bit? Very simple. You just use the 32 minus the prefix length, right? Then you get the numbers of host bits. I will give you a detailed example in the coming slide. For IP address 192.168.1.70x/27, you need to find out the sublets this IP address belongs to, the broadcast first and last available address of the corresponding sublet. So for /27, number of host bits is 32 minus 27, which is 5. Then 2 to the power 5, which is 32. That means that the size of each sublet is 32. Then the sublet address is actually the multiple of 32. If you are not good in arithmetic, I recommend a simple method. You just list those multiples one by one. How can you do that? Start with 0 and then add 32, 32, 32 and so on. Then you immediately get 0, 32, 64, 96, and then find out the multiple that's just less than the last byte of the IP address. In this case is 70x. So the multiple just less than 70x is 64 in this example. The highest IP address of this range will be coming 64 plus 32 minus 1. Remember to minus 1. It's not just 64 plus 32. 64 plus 32 will become the next sublet range. So it's 64 plus 31. That is 95. A more precise mathematical method is that you divide the last byte by the size. Usually you will get a non-integer number. But then you just care about the integer part. Take the integer, multiply with the size, then you will immediately get the sublet number. For example, in here, you divide 70x with 32, you should get 2 point something. You don't care about the something, you just take the 2. and then use 2 multiply with 32, you immediately get 64. Once you have the subnet number, you have the size. I already tell you how to calculate the broadcast. That's the last address of the range, right? And then the first available address is simply the subnet number plus 1, while the last available address is the broadcast address minus 1. Here I complete part 1 of this presentation. In this part, I have discussed the important technique of how to divide a Class C network number into different sublets, and also discuss one of the common questions in the examination, which is giving you an IP address. You need to figure out a subnet broadcast address and so on. So if you enjoyed this video, please give me a like. For the next part, I will continue to discuss some more common questions in the examination, and also discuss the cases for Class B and Class A. So please subscribe this channel. So finally, thanks for watching. Bye.